So hello everyone, welcome to my YouTube channel. So my name is Shreya Supasni, and I am excited to present a comprehensive overview of DevOps and its tools, which is a crucial topic in modern IT and software development. So in this whole video, we will explore what DevOps is, then why it matters, and how different tools help us achieve faster and more reliable software development and deployment. So, if you are new to DevOps or already familiar, this video will provide valuable insights. So, let's begin. So, starting with this slide, what is DevOps? So, to understand DevOps, let's break the word into two parts: deploy development and operations. So traditionally, software development and IT operations were separate teams. So developers would build applications, and then operations team would deploy and maintain them. So this approach often led to delays, miscommunications, and deployment failures. So DevOps merges these two functions to create a collaborative, automated, and efficient workflow. So there are like some key takeaways from this. DevOps is a culture shift that fosters teamwork. Then it focuses on automation to reduce human errors. Then it enables faster and more reliable software releases. So, for example, imagine if there is a team which is building a banking application. So, in traditional setup, developers might finish coding, but operations teams struggle with deployment due to there are like some conditions where there are missing dependencies. So, with the help of DevOps, automated testing, and CI/CD pipelines, uh, DevOps ensures smooth deployment and reducing downtime. So like this is basically what DevOps is. So there are like some key principles of DevOps. So DevOps is built on key principles that enable organizations to develop, test, and deployment software efficiently. So like the first principle we would say collaboration between teams. So DevOps fosters better communication between developers and IT operations. Then there are like some shared responsibilities which ensure that both teams work toward common goals rather than the separate objectives. Then DevOps automates testing, deployment, and monitoring using continuous integration and deployment pipelines. Then there are like automated testing and deployment. It reduces time to market for new features. Then faster iterations and DevOps mean better quality software with fewer bugs. So like these are some key principles of DevOps. If we think about companies like Amazon or Netflix, they deploy thousands of updates per day without downtime. This is possible because of DevOps only. So next slide. This is basically a DevOps life cycle. The DevOps life cycle consists of multiple stages that ensure smooth software development and deployment. So like there are some stages. First stage is plan, like to define project goals, user requirements, and features. Then second stage is develop, uh, to write, review, and version control the code. Then the next stage is test. It contains like to automate unit and integration testing. Then there is release, which packages and prepare the software for deployment. Then there is a stage called deploy, which roll out updates without affecting users. Then there is stage operate, which maintains performance, then the availability and security. And the last stage is monitor and improve. So basically it continuously observe and refine the application. If we take an example, a gaming company using DevOps ensures that each game update is thoroughly tested, automatically deployed, and continuously monitored for performance issues. So this was the basic DevOps life cycle. So now we will start with the actual tools of DevOps. Like various tools are used across different stages of DevOps. So if we classify them in categories, so there are like these seven categories. The first category is version control. uh, if we talk about version control, there are like some tools like git, then github, then subversion svn. If we talk about the second category, which is CI/CD, it is also called as continuous integration and deployment. So under that we have tools like Jenkins, GitHub Actions, then Circle CI. Then under configuration management and infrastructure as code (IAC), we have Ansible, then Puppet, then Chef. Then there is containerization and orchestration. So under that we have Docker and Kubernetes as tools. Then there is a category which is called as monitoring and logging. It has tools like Prometheus, then Grafana. Then under security and compliance, there is a tool called HashiCorp Vault. Also under cloud platforms, as we know, there are tools like AWS, then Google Cloud. So these are basically some of the categories of DevOps tools. So we will see one by one. So the first category is version control system. So what basically a version control is? Version control systems track changes to code over time, allowing multiple developers to collaborate on same project. So there are like some tools under this category. The first tool is git. The git is most widely used distributed version control system. Then there is SVN subversion. It is a centralized version control system. Then there is Mercurial, which is also a distributed version control system. So most widely used is Git. So we will see Git. So these are like some basic commands in Git. Uh, the first command we can say is git init. It initializes a new Git repository. Then there is a git add command which stages all changes in the working directory. Then there is git commit which commits stage changes with a message. Then there is a command called git push which pushes local commits to a remote repository. Then there are like basic git concepts. The branching concept is there which allows parallel development without interference. Then there is a concept called merging, which combines changes from different branches. There is GitHub, which is a web-based hosting service for a Git repository. It basically hosts Git repositories for collaborations, and it integrates with CI/CD pipelines for automation. GitHub is used by companies like Microsoft and Facebook to manage their code bases and streamline development. So this was about version control system. So the next slide is about continuous integration. Like what is continuous integration? Continuous integration is basically a practice where developers integrate code frequently into a shared repository. And there is continuous deployment. Continuous deployment is basically a software release process that enables rapid updates post automated testing. So we will see next slide. So here we have a proper definition like continuous integration. Developers frequently integrate code into a shared repository where automated tests are run. And there is continuous deployment where automatically deploys code to production after passing tests. So under this there are like some key tools. uh, Jenkins is the most popular tool under CI/CD. It is an open source automation server for CI/CD. Then there is GitHub Actions. It is also an integrated CI/CD tool within GitHub. Then there is Circle CI, which is a cloud-based CI/CD tool. So Jenkins, as we can see, most widely used uh, tool in CI/CD. So what Jenkins is? So Jenkins is an open source automation server that helps automate the parts of software development related to building, testing, and deployment. So there are like some key concepts in Jenkins, like key terms. So the first key concept is job. A job is a task, or we can say a set of tasks that Jenkins performs such as deployment or test. Then there is pipeline. Pipeline is basically a series of automated steps that define the continuous integration and continuous deployment process. Then there is node. Node is basically a machine that is a part of Jenkins environment. Then there is a master, the central Jenkins servers that manages jobs, nodes, and pipelines. Then there is a agent. Agent is basically a node that executes tasks assigned by the Jenkins master. Then there is a concept called plugin. Plugin is basically extensions that add functionality to Jenkins. So like these are the basic concepts when we try to use Jenkins tool. So like these are some of the features of Jenkins. Jenkins supports over 1500 plugins, which allows integration with any tool virtually or any technology in the DevOps ecosystem. Also, Jenkins pipelines can be defined as code in Jenkins files only, making them versionable, reusable, and easy to manage. Also, Jenkins can automatically run tests as part of CI/CD pipeline, which ensures code quality before deployment. So this was all about Jenkins. So now we will see about Docker. Docker comes under the containerization. So what is Docker? Docker is a platform which basically allows you to package applications and their dependencies into lightweight portable containers. So like in Jenkins, there were some basic concepts. If we try to use a Docker tool, there are also some key concepts which we should know. So there is a concept called container. Container is basically a lightweight, standalone, and executable package that includes everything need to run a piece of software. So this is all about container. Then there is a concept called image also. Image is basically a read-only template used to create containers. Uh, these images are built from Docker files. Then there is a Docker file. Docker file is basically a text file that contains instructions for building a Docker image. Also, there are like some basic commands in Docker. Uh, as we can see here, the first command. Command builds a Docker image from a Docker file. Then there is a command called docker run. This command runs a container from an image. Then there is a command called docker ps. This command lists all running containers. Then there is a command called docker stop. Then we put container id. So this stops a running container. If what the id we have given, it stops that running container. So these are some of the key features of Docker. Like Docker has consistent environment. Like it ensures that applications run the same in development, then testing, and in production environments also, which eliminates it works on my machine problem. Also, there are containers run in isolated environment, preventing conflicts between applications. Then Docker containers can run on any system that supports Docker. Like it makes easy to move applications between environments. Then the speed is one of the key features of Docker. Like containers start up quickly, allowing for rapid deployment and scaling. So this were some of the key features of Docker. Then we will start with Kubernetes. It comes under orchestration. Like basically, what Kubernetes is, it manages containers at scale. What is Kubernetes? Kubernetes is an open source platform for automating deployment, scaling, and management of containerized applications. So, like there are some key concepts, key terms which we should know before using the tool. So there is pod. Pod is basically the smallest deployable unit in Kubernetes, which represents a group of one or more containers. Then there is node. Node is physical or virtual machine that runs containers. Then there is a cluster, a set of nodes that run containerized applications managed by Kubernetes. And then there is deployment, Kubernetes object that manages the desired state of set of pods. So this was about the key terms in Kubernetes. Also, there are like some basic commands in Kubernetes. The first one is get pods. If we use this command, it lists all pods in the cluster. Then there is this command apply, which applies a configuration file to create or update resources. Then there is this command scale deployment. uh, Here it we can define the number. It scales the deployment to, as we can see here, we have mentioned three, so it scales a deployment to three replicas. Then there is command delete, which deletes a specific pod. Here we can specify the name of pod. So these were some of the basic commands in Kubernetes. So this these are some of the key features in Kubernetes. Like Kubernetes can automatically scale the number of containers based on CPU usage or other metrics. Then there is load balancing. Kubernetes distributes network traffic across multiple containers to ensure high availability and reliability. Then there is self-healing, like Kubernetes automatically replaces or reschedules containers that fail or do not respond. Then there are rolling updates, like Kubernetes allows you to update applications with zero downtime by gradually replacing old containers with new ones. So like these were some of the key features of Kubernetes. So in this part we have seen up to containerization, like we have covered version control, then CI/CD, then configuration management and IAC, and containerization and orchestration. So in the next part, we will cover the next three categories. So I hope you have got enough of idea what these tools are. In next video, we will see the next three categories. So that's it from my side in from this video. So let's meet in the next video. Thank you.